Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about civilizations at the end of time, or super advanced civilizations, truly mega, super, hyper, ultra advanced civilizations. What would they do near the end of the universe when all of the other normal stars are long gone and the only things left will be black holes in total darkness? Only the leftover ghost phantom light of previous galaxies and stars will be still roaming around the universe. But when all the stars are dead, what possible way could a civilization survive? So in our universe, in a really paradoxical kind of effect, the smallest stars actually live the longest time, and the biggest stars, the bigger the star is, the shorter the lifespan of that star. And this is because for small stars, they use their fuel efficiently. They have something called convection cycles, which means that all of their fuel gets circulated around them efficiently, and so these stars can live for trillions of years. Our universe has been here for 13.7 approximately billion years. So all of these small stars are still in their very early infancy. So in a way, this is just the beginning. But these big supermassive stars, they can explode in a few million years or a few 100 million years, depending how big they are, because they have no method of recycling the fuel that they have. So they use up all the fuel in their core, and then they just blow up, creating enormous supernovas. And this is a way how our universe gets elements, because with this heat and pressure inside these enormous stars, all the heavier elements are created, and then they're spewed across the cosmos, which new solar systems and new galaxies and new stars form from. But anyway, at the end of time, so how could possibly civilization survive there? So one way would be to thinking about this would be black holes. There's a way to get energy from black holes, and the way you could get it would be by Hawking radiation. So all black holes emit a type of radiation. They're black, so they don't emit any visible light. They're not glowing, but they do emit a really minuscule scale of radiation, and this is called Hawking radiation. So virtual particles pop in and out of existence at their edges, and some of these virtual particles escape from the grasp of the black hole. Now, what you could do if you're truly super advanced civilization, you could somehow harness that radiation around the black hole. Some other methods are a bit simpler, like some pulley or lever or some kind of generator effects, like you take something heavy and tie a rope around it, throw it in the black hole, and that pulls something and creates energy. You can do it that way. Black holes also have this accretion disk, so this disk of superheated plasma around the black hole that has tremendous energy and creates incredible magnetic fields. So it would be possible maybe to tap into that magnetic field, or that somehow use that superheated plasma in some way. Truly enormous mega projects are needed for this, but nothing in the laws of physics that says that we couldn't do it. So an interesting thing to note that with this Hawking radiation, actually the bigger the black hole, the slower it radiates its Hawking radiation, but the smaller the black hole gets, the more it radiates away, the faster it starts to radiate. So in the last thousands or even in the last millions of years, it will produce significantly more of this Hawking radiation, and it will grow exponentially as the black hole gets smaller and smaller, and at the end it will just explode in light and radiation. And this energy can be used in really interesting ways. So one interesting thing to also note is that these civilizations living around these black holes most likely will be digital. They won't be biological or anything that we would recognize as biological, because the amount of radiation coming from these black holes by this radiation is just so minuscule that there is no way to keep a living being alive who has metabolism, and we radiate heat away by our bodies, and we burn so much energy by thinking. But in the distant future, it would be a lot colder, and that means that calculations can be done that would be impossible in today's hot universe, where radiation is coming from everywhere, all different types of radiation, when we don't even notice it. So in the far future, it would be possible by taking account the absolute limits of computation, so the most efficient computation that you can make. You could run a civilization around the black hole on the energy of a normal desktop computer, and this civilization could be the scale of a type 3 civilization. What I mean by type 3 is type 1 Kardashev scale of civilization, not Kardashian scale, but Kardashev scale was an interesting thinker and came up with these ideas. And so type 1 would be a planetary civilization that would be able to harness all the energy from the planet. So all of the wind, all of the solar, all of the geothermal, all of it, all the energy on the planet, they could harness it, type 1 civilization. Type 2 could harness all the energy from the parent stars, so they could build mega structures, Tyson spheres around the stars. And they would harness almost all, if not most, of the radiation coming from the star, and that would be incredible amount of radiation. And then a type 3 civilization would be a civilization that would be able to harness all the energy from all of the stars in their home galaxy. So these would be hundreds of millions of stars, billions of stars. So around the black hole, you could have this type 3 civilization taking into account the absolute limit of computation in really, really cold. Actually, calculations get way more efficient as the universe cools down. So a really smart civilization that would think about the future carefully, they would just hog all the matter and energy and go into some kind of hibernation and wait until the universe is cooler, and then start running the party, their actual lives. And also to notice, because this radiation coming from black holes is incredibly small, also in simulations, if you have simulations of virtual beings, you can adjust the time. So even if you get really minuscule amounts of energy, you can have the birth and death of stars be a blink of an eye. You can have a million years go by like this. It would be nothing, and an interesting effect would be that this would give them time to run these calculations at the pace that they're getting energy. But also, if you imagine that you're around this one of these black holes and you have your computation system, whatever it is, and a million light years away there is another civilization around another black hole, then you could actually communicate with them, keep sending radio waves back and forth, or well, maybe some other radiation. We're thinking in radio waves, but in the future there will probably be something way different than radio waves. It's quite primitive way, like saying that, you know, people in the future will be using smoke signals, like probably not radio waves. But just an example, radio waves, some kind of communication, it would take in objective time in the universe, from someone looking outside, it would take still a million years to get to that other black hole. But the point being that you could slow down time so drastically that million years could be a second. And then you can communicate with this other civilization that's a million light years away. You could be on the phone talking to them, someone who's a million light years away, and it would be 1 second delay maybe. Or absolutely, it could be in real time. You could be both in the same place, same time, in the same virtual reality. In fact, this simulation could be shared across galaxy or entire galaxy groups even. It's fascinating to think of the possibilities, because in the outside universe, a million years would be nothing. Black holes live incredibly long time. They live for trillions and trillions and trillions and trillions of years. So a million years really isn't nothing. It's like saying in our lifetime a second. It really isn't much. Incomprehensibly long lifetimes is what black holes have. So just for some sense of perspective, our universe is 13.7 billion years old. So 13.7 times 10 to the power of 9. So 10 followed by 9 zeros. Then with a trillion, 1 trillion, we have 12 zeros. So 1 followed by 12 zeros. And a really large supermassive black hole can live to 10 to the power of 100 years. So 10 followed by 100 zeros. That's the amount of years that a supermassive black hole could potentially live. So vast, unimaginable timescales, even talking about our normal universe, what is a million year? Our brains just simply have not evolved to be able to comprehend this. But just for some sense of perspective, in a weird kind of way, most of the rich life and experience in the universe might actually exist during the time of these black holes. So most of the experiences in our universe might actually be virtual. And after all the stars and the shiny stuff is gone, actually, you know, incredible, vast civilizations and things happening could happen in complete darkness. So I think that's just absolutely baffling to think about. So with black holes, as I said, they live incredibly long times. So, you know, would you worry about time running out? Of course, if you make a million years a second, then it would be a little bit faster. But so the important point to notice is that as the black hole gets smaller, it starts to radiate more away. So as you start getting more energy from the black hole, you running this simulation, you could actually speed up your simulation. So increasingly, for every second of real time, you are experiencing more and more real seconds in your own subjective time. So you could, for the increase of output from the black hole, you could sort of turn up the sort of scale of your simulation and also experience more time for every objective second in the outside universe. So as this black hole starts to evaporate like truly incredibly in the last like 10,000 years or 1,000 years, you could really experience a lot of life, because so much radiation energy is given away, and you have this computational limit, these super cold vacuum computing machines, whatever you would have. So at the end of the black hole's lifetime, you could actually have most of your experiences, because it's radiating away so much energy, and you can just crank up the simulation to sort of handle that kind of volume, that kind of energy. And thus, for the last like a year or something, you could have trillions of years of subjective experience. Just think about it. For the last few years, you could have trillions of more years, because so much energy is given away, and there is no limit how fast or slow you can run your simulations. That's the interesting thing about here, thinking about this. So these are just some thoughts about civilizations at the end of time. I think it's really fascinating to think about this. I got my inspiration from reading some sci-fi books and reading some subreddits on this topic. I don't know why I'm like stuttering but I hope it was interesting in some kind of way. This is fascinating for me to think about. So it might be possible, also interesting to think about what the true end will be. Like, these beings will have vast amounts of time to think about. They would have a choice. Do they go with numbers, so the most possible beings, or will it just be like one being who wants to live for trillions and trillions and trillions of years at the expense of not having to simulate anyone else, and just simulates a perfect world for themselves? But it's interesting to wonder if during the time, and surely they would be able, by that time, they would have some super intelligent artificial intelligence systems. They could maybe figure out the way to reverse entropy. They could find a way to maybe build a wormhole to another dimension, another universe, make a new baby universe that they could actually live in some way. It's fascinating to think about, but maybe that truly isn't possible, because it's possible that fundamental particles, photons, stuff that atoms are made of, protons that atoms are made of, they could finally decay as well. So even they could finally maybe fall apart. So it depends whether or not this is true, what will happen at the end of our civilization. But it's interesting to think, because we have time to think about this, so it's like no hurry. I'm sure we'll get some better ideas and time to think about it. So again, I hope it was interesting in some way. If you have any thoughts about this, please share them in the comments, and of course, thank you so much for watching, and take care.